And once you click on nose cone, you'll probably see something like this pop up. Now, what this box is for is if you go to a website and you want to buy a specific nose cone, and if you can find it online at any of these websites, so you can see Balsam Machining, SEDS. They also have Lock Precision, MadCal. They just have all of these different companies that you can take and pick a nose cone from. Typically, at SEDS UNLV, we 3D print our nose cone. And if you have paid your membership dues, that will be free of charge to you as a member. Now, that is relative to change, but at the time of recording this video, that is our current rule. So, for the nose cone, we typically just ignore that window like I just did. We close it, and then we make our own nose cone because we can actually export this as a 3D model and then 3D print it later on. To start off with, we want to go ahead and click on our nose cone shape. So there's a bunch of different shapes that we can have our nose cone as, but for the most part, we actually want something that's more rounded. So you can see in this little diagram right here, we have conical, secant ogive, tangent ogive, elliptical, power series, LLH hack, and then von Karman. These are all the different kinds and all the different names of nose cone heads. And what all of these names are is basically the graph type to make that kind of shape, if that makes sense. So conical is just a conical line. An elliptical is just an ellipse that's stretched out. Power series, very similar thing. It's just more of an equation to figure out. It's basically a lot of math, but thankfully OpenRocket does it for us. And you can see here that the more pointy the nose cone is, the worse that it is. You actually want it to be more rounded, mainly because it allows the air to pass through or pass by your nose cone a lot easier than sticking to a flat surface. So, knowing that, I'm going to go ahead and pick a hack series for my nose cone. But you can choose realistically any one of these that you want. If you watch the movie Dictator, you can make it conical and make it pointy because it looks scary. It's up to you. But I personally like the hack series. And you'll see that my nose cone shape immediately changes. And you can see there's a bunch of different new values that you can also change. To start with, let's look at the shape parameter. So some of these nose cones have a shape parameter and some don't. As you can see, I just switched over to the ellipsoid and that does not have a shape parameter. So for the shape parameter itself, what it does is it just changes how the nose cone actually looks. It basically moves the radius of the equation inside of the hack series nose cone. But the shape parameter isn't very important unless you just want to Rico cut all that out. So as you can see here, we have our first parameter called the shape parameter. And some of these nose cones do not have a shape parameter. The main thing that this changes is just the way the nose cone end looks. So you can make it look more rounded, you can make it look more straightened. For my case, I'm just going to keep it at 0. Then here you can change the length of your nose cone, so the overall length. You can make it super long if you really want to, but I'm probably just going to keep mine around 3 inches. And base diameter, that's really based on your body tube. But keep in mind that this value means this distance right here. It does not mean the shoulder diameter. It means the base diameter right here. So you want it to be equal to the outer diameter of your body tube so that it's flush with your body tube. And here we have our wall thickness. Now, typically, I tell people to have it around 0.125 inches. And if you say pick centimeters or any other form of measurement, you can go ahead and just translate that to that measurement. Or if you want, like say, if I switch this over really quickly to centimeters for whatever reason, and I want inches, you can actually just type in 0.125 inches, and it'll automatically calculate that for you. I'm just going to keep mine in inches for now. And then, last thing is we want to look at this component material right here. Now, the component materials are very important for OpenRocket because what it does is it calculates around the mass that the item should have in real life. So it's kind of just guessing what the weight would be, but it's a very accurate guess based off of the material that you give it. So for our purposes, since we're going to be 3D printing, you'll see I have ABS here, but that is something that I added myself. They should also have PLA plastic right here. And PLA is also one of the most used 3D printing plastics. So I would just suggest using PLA as your component material. And now, for the nose cone, really the last thing we have to look at is this box right here. This is called our shoulder. And it goes inside of your body tube to keep your nose cone attached to the top of your rocket. So, your shoulder should have an diameter, or the same diameter, as the inner diameter of your body tube. And I'll go ahead and show you how that would look in just a little bit when we add in our body tubes. But that is mainly so that it is a snug fit and does not want to come out. Next, we have the overall length. Typically, I recommend at least 2 inches in length. That may seem a little long for this rocket, but you got to keep in mind that the base diameter for this is less than an inch, which is really, really small. Realistically, the base diameter for a nose cone is going to be around 3 inches. And you can see that's a pretty fat nose cone. I'm probably going to set the length to 5 inches now, just to make it look a little bit more real. Oh, apologies. The base diameter will probably be around 2.16. And that's just off the top of my head based off of some rockets that I've seen. And you can see here that the shoulder's diameter is a lot less than the nose cone itself. And we can fix that in a little bit once we add our body tube. But for now, we want a shoulder length of at least 2 inches. And then the thickness should be the same as the thickness of your nose cone. So I'm going to put that as 0.125 or 1/8 of an inch. And then I'm just going to hit OK. That's pretty much done for your nose cone. We're going to come back to it because of this shoulder distance. Looks a little weird. And we're also going to go back for the base diameter so that we can fix that to the body tube. And let's go ahead and continue on with the body tube. Alright, so what we're going to do is click on this tab right here. And the same thing will pop up again. It'll show all the different body tubes that you can find. Typically, we just make these custom as well. Well, we don't make them in shop, but you can find them online. And the ones that you find online will already have all the dimensions that you need. So we don't usually pick from this list. We just find a body tube online that you can buy and then take those dimensions, then import it to OpenRocket. So I'm going to go ahead and close this for now. And you'll see it already has like a basic length of around 15 inches. Typical rockets are actually around 24 inches in length, 24 to 36 for a level 1 rocket. And you can really make it as short or as long as possible, just as long as it reaches the height that you want or the stability that you want. This is your first rocket, so you want to have fun with it. I'm going to keep the length at what it's at, and then I'm going to set my outer diameter to, let's go 2.25. In reality, we would be looking at a website right now with a body tube that we found. Here, I'll go ahead and show you actually. So I like to use this website called Apogee Rocketry. And you'll see this is the website right here, apogeerockets.com. And you can go to the shop here, and then you can look for building supplies. And it'll list all the different building supplies that you may need. I've personally bought from this website before, and they are pretty reputable. So I would recommend it for first-time builders. Then I would head over to body tubes right here, and you can see they have all these different kinds of body tubes. I'm just going to go for the 29 to 54 millimeter body tubes, just to make it a little easier. And then I think I'm going to go ahead and go for a 38 millimeter lock body tube. So you can see this listing has the inner diameter, the outer diameter, and the length and thickness. And you can see the length that it comes in is 34 inches. So we're going to take this and put it into OpenRocket. So you can see here, let's keep our length how it is. Maybe let's do half of 34. Or let's do 34 divided by 4 or 3. Why not? Let's do a third of 34. So that a third of our overall length is the upper body tube, and then our lower body tube is 2/3. And then we're going to have an outer diameter of 1.635. Or if you want, just like I said before, you can switch it over centimeters and just type in those centimeters. And then we have our inner diameter of 1.525. Oh, I forgot to delete these. And then it'll put the wall thickness in for you. And you can see that's what our body tube would look like. And it seems like I massively oversized our nose cone, so we'll go back and fix that in just a minute. But for now, we will also want to select our component material so that it can automatically calculate what the weight would be in real life. So you can see here, it's made out of brown craft paper. So we're going to go into this list, and then we're going to find craft paper. And typically craft phenolic is also the same material as craft paper, it's just a different name. And there you go. Now the last thing is you want to kind of expect what kind of paint that you plan on putting on your rocket. So say if you plan on spray painting, I would suggest selecting the regular paint. If you plan on not painting it at all, you can do rough unfinished, but typically we recommend painting so that it's a smooth surface. All right, and that's pretty much it for the body tube. So I'm just going to click OK, and then we're going to go back to our nose cone and fix it a little. Okay, so for our nose cone, you'll see that we have our base diameter as 2.16 right now, which looks way off. Now, the nice thing about OpenRocket is you can actually click this little button right here that says automatic, and then it'll automatically shrink to the size that you want. Now, the one thing that does suck is for your shoulder that we have to change as well, it does not have an automatic button. So you actually have to go to your body tube, look at the inner diameter, not the outer diameter, because this shoulder is supposed to fit inside of your body tube. So you want the inner diameter of your body tube. So we're going to go ahead and copy this inner diameter. We're going to go to our nose cone, back to our shoulder, and we're going to change the diameter to that inner diameter. And you'll see that it has a slight gap right here. And that's because that is the thickness of your body tube. And you can go ahead and just hit OK. And there we go. That's all the fixes we need for our nose. All right, so next what we're going to do is add a second body tube. As you can see, inside of a rocket, we actually want to have two body tubes. We want an upper body tube or a lower body tube. You can actually have one singular body tube if you would like, so that you can have the parachute pop off the top and have your nose cone separate from the top of your rocket. That is a different kind of rocket, and we've done those in the past. I would just like to show you how to do the more difficult two body tube rocket instead of the single body tube, just so that it's a good application for both kinds. So for our lower body tube, you can see we have this cylinder right here, and this is called a coupler. And what it does is it sits between the upper body tube and the lower body tube to connect them together with a friction fit. That basically just means that it's really, really tight to pull off, but you can still pull it off because you need to separate the two body tubes to let your parachute come out. You'll also see that there's another section called the bulkhead right here. And that's actually where your shock cord is going to attach to pull out your parachute. So imagine as if this is the entire upper body and this is the entire lower body. And it will separate at this coupler right here. So if we have a shock cord tied to your bulkhead right here, and the other end will be tied to your inner body tube, this shock cord will extend outwards and will pull out the parachute from your lower body tube. Alright, so to start off, we're going to go ahead and click on this body tube so that I can add the coupler to this body tube, since it'll be attached to this end right here. I'm just going to click on tube coupler right here. And you'll see this giant list show up, and you actually just want to skip this list again because we make our own custom couplers. Typically we can 3D print them, or just like before, you can buy them offline. You just use the dimensions from online. And I'm just going to go ahead and hit close and ignore that little tab. So typically you want the outer diameter to be automatic, so that's why this little check mark box is already check marked. And you want your wall thickness to be the same as your nose cone, so 0.125. But that is only if you are 3D printing. If you are buying your coupler, then this wall thickness should be the same as what the manufacturer's website says. So, since I plan on 3D printing this coupler, I'm going to go ahead and select PLA like we had before. And then we're just going to go ahead and move this so that half of it is sticking outside of the body tube. Because you have to remember, this is supposed to be in the center of both the upper and the lower body tube. So since my length, I'm going to set this to 3 inches. Typically, we recommend at least a minimum of 2 inches. So since my length is at 3 inches, I'm going to do 1.5 inches outside, so that it's exactly in the center of both body tubes. And now let's go ahead and continue on by adding our second body tube. So for our second body tube, we actually have to go up here and click on the sustainer once again, so we can add a body tube at the end of our rocket. And then you'll see that this little list pops up again. We're just going to close that once again. That list will eventually get pretty annoying. And if at any time you want to reopen that list to look at the parts and maybe research them online, you can actually click on this parts library right here, and that'll show up. And that works for any part. So, same thing as before. We have the length, the outer diameter, inner diameter, and wall thickness. And because the body tube that I had selected was 34 inches, and I believe my upper body tube is around 11.33. I'm just going to change that to 11 so it's easier to measure in real life. And then I'll go ahead and double click on this, and then I'll say, let's make it 23 inches because that'll be the rest of our 34 inch. And you'll see it's a pretty long rocket. You don't have to make it this long. You can cut down the body tube. You can have excess material if you want. It's really up to you. And then you'll see the outer diameter and inner diameter basically copy themselves from the other body tube. So you actually don't need to fill that out. And then you just want to make sure that the component material is the same as the other one. So for the component material, I chose craft phenolic. So I'm going to do the same here. And then that's pretty much it. So I'm going to hit OK, and we're done with our lower body tube. Okay, so the next important thing will be to add your actual motor to your rocket. Now, the motor is actually what you build your entire rocket upon. So you want to start off by selecting your motor and then building your rocket to make sure that your motor fits inside. So to mount your motor, what we typically do is we use an inner tube. As you can see, there's a component for it right here. So I'm going to click on it. I'm going to close this. I'm just going to add that inner tube. And then, let's say I have selected my motor. Right here, I have the level 1 motor stock sheet that you guys have, and you should be able to select one of your motors from this list. I am going to personally select a 29 millimeter in diameter motor. And then I think I will pick the H195NT. And that designation is just saying how powerful the motor is, along with the actual color of the propellant. So, now that I know my diameter is going to be 29 millimeters, I already know that my inner diameter needs to be 29 millimeters. So I'm going to change this to millimeters, and I'm going to change this to 29, and you'll see that it automatically changes. Then the outer diameter is really based off of the inner tube that you choose. So just like before, I'm going to go over to Apogee, and I'm going to look for a 29 millimeter building supplies, a body tube that is 29 millimeters. So here's that section right here. And I'm going to go ahead and click on this one. So you can see there's different kinds of tubes called 29 millimeter engine mount tube. There's the body tube. You can really use any of these tubes. I would just suggest the engine mount tube because typically they are cheaper. So for the engine mount tube, you'll see it has a length, has the inner diameter and the outer diameter. So I'm just going to go ahead and copy this outer diameter because the inner diameter needs to be 29 millimeters so that the motor can fit. So the outer diameter will be 1.210 inches. So let me enter that in. It will be 1.21 inches. And it looks like it didn't take my 29 millimeters before, so I'm just going to re-enter that. And there we go. Now that's the correct size. And if you look back at Apogee, I believe the length was 7 inches. So I'm just going to go ahead and type in those 7 inches. And there's your inner tube. And you want to just make sure that the component material is the same as Apogee components as well, the one that you plan on buying. And this one is craft paper, just like the other one that we saw. So this will actually be craft phenolic. All right, and after that, you can just hit OK, and that's your inner body tube. So now that we have our inner body tube, we can actually add our motor to this so that we can actually start doing our simulations. So that's where we're actually going to go over up to the top left, and we're going to click on this Motors and Configurations tab. Now, this tab, you can see it has all this empty space. It's really just to show you what motors you have selected. So right now it's empty because we don't have any motors. But say if I wanted to add my H195, right? I would go ahead and select where I want that H195 motor. Do I want it on the upper body tube? Do I want it on the lower body tube? Or do I want it in the inner tube? Now, since this is going to be our motor mount, we actually want it on this inner tube right here. So I'm going to click right here on this little check mark that says inner tube. Then, after you check that, we can go up here and click on New Configuration. And this little box will pop up right here. And this box will have every single kind of motor that you could really think of or buy online. And since I'm looking for an H195, I'm going to go ahead and type that in. H195. And you'll see right there, it automatically populates. Typically, it's an Aerotech motor, so you want to look at that. And I'm just going to hit OK. And there you go. Now we have our motor inside of our rocket, and we'll actually start to see some values populating. So just to show you next is right up here, we have a flight simulations tab as well. And you can see once we select our motor, we'll actually have a simulation. Now, right now, our values aren't looking pretty good. And you can see our apogee, or our highest point, is only 176 feet. That's because we don't have any fins right now. So it won't really fly. It's kind of just going to fall and then crash into the ground. And you can see the max velocity, we have the max acceleration, we have our time to apogee, we have our flight time, and this is your ground hit velocity. Alright, so for this ground hit velocity, we typically recommend around 20 feet a second to 26 feet per second. And you can see this is a lot higher than that. And I'll show you how to change that in just a little bit. So let's head on back to our rocket design tab, and let's actually go ahead and add those fins in. One last thing that I forgot to mention is for your inner body tube, we actually want to add something called centering rings. And what that does is it just makes your inner body tube center in the middle of your body, your outer body tube, just to make sure that it's not slightly tilted or not slightly angled so that your rocket can fly as straight as possible. So to add in those centering rings, we can just click right here. And you'll see this shows up again. I'm just going to hit close. And you can see you have an outer diameter and you have an inner diameter. So your inner diameter should actually be the outer diameter of your inner tube. But to start off with, we want our outer diameter. Oh, apologies. I actually added this to the wrong item inside of the design tree. And you can see that because when I click the automatic, it automatically snaps to the inside of the inner body tube. But we actually want it to snap to the inside of the body tube. So I'm actually going to hit cancel and hit undo adding this component. And we're going to click right here to our body tube and then add our centering ring right here. We're just going to hit close on this once again. And you'll see this time that the outer diameter is correct and the inner diameter is correct. So now all we really have to do is slide this to the positioning that we want. I typically recommend 3 centering rings, but you can have only 2, but you need to have at least 2 centering rings. And typically your centering rings are going to be made out of plywood because at the makerspace here at UNLV, they actually have a laser cutter that we can use. So I typically recommend to laser cut both your fins for your rocket and your centering rings. So that is our first centering ring done, and we actually need to change the thickness really quickly. I forgot about that. So at the makerspace, they typically have either an 1/8 of an inch or a 1/4 inch sheets of plywood. And we typically 3D print the same thickness as well. So if you plan on 3D printing your centering rings, you want to have either an 1/8 of an inch or a 1/4 inch thickness. So for our purposes, I'm going to set it to an 1/8 of an inch or 0.125. And then it'll automatically show up there. Then I'm just going to hit OK because that's the end of our first centering ring. So for the next centering ring, you can actually come up here and right click on it. Then you can duplicate it. So that all you have to do is just move it, and it has all of the same settings as the first one. So you can see here it's duplicated. I'm just going to move the positioning so it's a little center on the inner body tube. I'm just going to hit OK. Then I'll do the same for the last one. I'll just hit duplicate, and I'll say I want to move this to right there. And there we go. Now, another thing that I want to show you guys is the position relative to. Now, this is pretty important because it's how you move your components inside of your rocket. Typically, it'll start off with bottom relative to, or bottom of the parent component, which basically means it's measuring from the very bottom of this body tube to the very top of this body tube. And you can see that because our parent component, or the component that the centering rings are underneath, is this body tube right here. So say if for whatever reason I want this to be 5 inches in on this direction, I can go ahead and type in 5. Oh, I forgot. So it's actually inversed. So you want to type in -5, and then it'll go 5 inches in from the bottom of your body tube. I'm just going to keep mine at 0 because I want the centering ring to be at the bottom, but you can always change that later. Now, I'm just going to hit OK. And there we go. Those are our centering rings. Now, let's go ahead and finally move on to our fins. So I typically like to do the freeform fins, mainly because you can add a little bit of style to your rocket and make it look a little bit cooler. But just like the nose cone, you can see in this diagram right here that the rounder an object is, the better it is for air or aerodynamics. So theoretically, the elliptical fin is actually the best fin that you can have for stability. Stability is something that we look at, or this value right here, to see how good your rocket is at flying. You can see right now, mine is at a negative 57.8%. That's not good at all. Typically, we recommend a positive 10.3 to 10.9 stability percentage. So that's what I would also recommend.